Shall we have a little look and see what we find? So if we look at this first one, what we need to remember is when we talk about delocalization, we're not talking about is the molecule as a whole delocalized. We just need to know, is there a delocalized system in there? Because if there is, it will change the reactivity of all the atoms involved in it. So in this case, you've got a double bond up here. There is no single carbon between it to another double bond. So those two would have some delocalized character. You've got another one up here, which again, there's no carbon, single carbon in between it, even down to this one down here. But if we look across to this final double bond over here, what we can see is there is that carbon in between. So that one at the end wouldn't be involved in the aromatic delocalized system or the delocalized system. Yeah. So all the bits now highlighted in red can all be part of the delocalized system, which means electrons in that area will be distributed. And then on the second one, it has a small area here that would be considered delocalized. The carbonyl bond, which we'll talk about at the end of the week, isn't, but this double bond and this triple bond are all connected together in this series of interlinking p orbitals. Okay, so the key thing to do from this is just to remind yourself when you're looking at molecules, think about what the bonding means. Sigma bonds are fairly straightforward, but once you start seeing double bonds and triple bonds, you need to think they're pi electrons, and they can do slightly different things. So they can delocalize if it's available to them.